Hello everyone, my name is Denis. I am working in the Vision System Lab as a junior research fellow at the Institute for Information Transmission Problems. Also, I am a PhD student at Moscow Institute of Physics and Technology. Today, I want to talk about the problem of the underwater images simulation methods based on terrestrial images. These methods widely used for testing and developing underwater image enhancement algorithms. Well, due to attenuation and scattering in the water medium, underwater images suffer from color distortions and contrast degradation. Underwater image enhancement algorithm used for robot navigation, detecting drowning people, underwater archaeology, and underwater image beautification. Here is an example of such enhancement. To evaluate the quality of the algorithms, widely use the following quality assessment scheme. As a rule, a statistic of a certain image comparison metric serves as a formal criterion for the quality of the algorithm's performance. This metric is calculated on a set of images in which an ideal target image is specified for each input image, and the result of the algorithm is compared with this ideal image. On this slide, you can see illustration of the scheme. So, in the top center of the slide, shown the underwater image taken in the turbid colored water that should be enhanced by the algorithm. On the top right, the image of the same scene taken in the clear water, which is used as a reference. The underwater image first processed by the enhancement algorithm. The result is shown in the bottom center, and then this result compared with the referenced image. To evaluate according to this approach, we need a special data set. The problem is that direct collection of such data set is difficult, and that is why the simulation of underwater images based on terrestrial images is widely used. The image formation model used in such simulation can be written as follows, where T is a transmission which decreases exponentially with distance to the object, and B is a scattering that, on the contrary, increases with distance. Transmission and scattering vary with channel. And this should be noted because, for instance, transmission for the red channel may decrease faster than for green and blue channels. So it is clear that the accuracy of the simulation is very important. On this slide, you can see the results of image enhancement algorithm based on convolutional neural network that was trained on the simulated images. In the first row, we can see that algorithm succeeded in an enhancement of the simulated underwater image, but failed on a real underwater image taken in very turbid waters, shown in the second row. In this work, we find out that simulation algorithm used today inaccurately simulates the noise of underwater images, and this simulation error differs for each channel. Actually, real images it is clear that real images have noise, and it is clear from the image formation model that during the simulation, image noise will be suppressed. This slide illustrates this problem. Again, on the first row, we can see that some enhancement algorithm succeeded in enhancement of the simulated underwater image. But on a real underwater image, this algorithm produced various color artifacts. And this problem cannot be detected while testing on the simulated images. In this work, we solved this problem by incorporating the noise model into the underwater image formation model. Let's talk about the noise model of the real images. To model the noise, we use Jahne's model, which states that variance of the camera signal linearly depends on its mean value. This model was verified on the real data, and here we show our verification of this model for some camera. On the left is a raw image with color targets in the center. And on the right, we plot the dependence of the signal variance on its mean for the pixels of color target. On this slide shown the results of noise simulation. On the right, you can see image without noise, and on the left, the image with noise simulated according to the formula of the slide. Here you can see the results of incorporating noise into underwater image formation model. We propose stochastic underwater image formation model and show the results of the simulation using this model. On the left, we show the image without noise used in simulation, and on the right, shown our simulation results. On the zoomed images, one can clearly see that the noise level of the image simulated according to the proposed stochastic model is higher than the noise level of the image simulated by baseline method. On this slide, we show that according to our model, the signal-to-noise ratio of the underwater image decreases with decreasing transmission. But the signal-to-noise ratio of the image simulated by baseline method is increased, which contradicts our model. Using the developed stochastic underwater image formation model, we propose a novel stochastic simulation method. For each pixel, we estimate the parameters of the noise that should be added in the simulation. The variance of the simulated signal is compliant to the developed model. On the zoomed images, we clearly see that the noise level of the image simulated by the proposed method is higher than the noise level of the image obtained by a baseline method. For comparison, on this slide, we show the restoration results of the terrestrial images from the simulated ones. Knowing the transmission and scattering parameters used in simulation, one can straightforwardly restore terrestrial images from underwater ones. We see that the signal-to-noise ratio of the restored images from proposed simulation is less than signal-to-noise ratio of the image restored from baseline simulation. So, to sum up, in our work, we highlighted the problem of underwater image noise simulation, proposed the stochastic model of underwater image formation. Using proposed model, we shown that baseline methods inaccurately simulate the noise of underwater images, and incorporating developed model, we proposed a stochastic method to simulate underwater images. Thank you for your attention, and have a good day.